At the screen visible?
Yes, sir.
So, today we are going to discuss about the support vector mission. So, SVM stands for support vector mission. Support vector mission. Okay, it stands for support vector mission. So, it's simply like a linear equation. So, it's simply like a linear equation. It's the x-axis and y-axis. Let me take an x-axis and y-axis. So this is my data points, which is present in a x-axis and y-axis. This is my data point. So first, we need to identify the hyperplane here. This is a hyperplane. This is a hyperplane. So simply in the form of y equals to mx plus c. Y equals to mx plus c. Or we can also call it as a marginal plane. So here we need to identify two more planes. This is a dotted line representation. So these are called as a marginals. These two are called as a marginal planes. So in middle of the line is known as a hyperplane. So the two lines layers which is formed by these are called a marginal plane. So the distance, if you increase the distance, the maximum plane will be touch the starting point. Maximum plane will be touch the starting point. So that is the starting of a data point divisions. That is a data point division. So here, so this is x-axis and y-axis, right? Consider x minus x, y minus y, right? X minus x, x minus y. So if you draw a line like this, slope, what is the slope? -1. It's towards the negative side, that's why it's a -1. And what is the value of this point? Like 1, 2, 3, 4, -4, comma 0. -4, comma 0. Value of this is -4, comma 0. What is the value of this? So 1, 2, 3, 4. 1, 2, 3, 4. The value of this is 4, comma 4. 4, comma 4. So we can easily identify like this. So y equals to mx plus c is a hyperplane, right? Y equals to mx plus c hyperplane, where m is a slope. We already know about this. Where m is a slope, where c is a intercept. C is a intercept, right? Where c is a intercept. So this is also look like a ax plus by plus c equals to 0. We can also write like a ax plus by plus c equals to 0. So it is a straight line equation. It is a straight line equation, right? It is a straight line equation. So now y equals to minus c divided by b, comma minus ax divided by b. Can we write like this? Minus like the separating by the a. Okay, we can write it. So simply if you want to expand this thing, so ax plus by plus c equals to 0. So by equals to minus ax, comma like minus c. So y equals to minus ax divided by b minus c by b. Same thing written here. Okay, we can also make like this. So where if you have a multiple bit lines where y1, x1, plus W2 X2 W3 X3 and so on plus B, where B is a bias, where B is a and so on B. Okay, for the multilinear regression like that, multiple points. If you have a multiple points, we can say it is a bias. So if you want to short form like W inverse of X plus B, we can also write this is as a W inverse of X plus B, right? So where we have both vector plus magnitude, vector plus magnitude. Here, vector plus magnitude, vector plus magnitude. So both we are in a linear regression, we have one is positive, another one is a negative. So WT of X plus B equals to 1. This is represented for the positive. WT of X plus B equals to -1. This is represented for the negative. So this is a positive slope. This is a negative slope. Negative, positive. Okay, calculate this. Negative is already positive 30, negative positive. Okay, cancel out. WT of X1 minus X2 equals to 2. X1, X2. Two lines. This is a two lines, right? We cancel. Here we have a two lines. One is positive, one is negative. So that's why I mentioned this. Bias will be cancelled. Bias is cancelled. We enter bias. We enter bias. Bias is cancelled. Okay. So apply the magnitude for this below the magnitude like x1, x2 divided by W of mod of W and W equals to apply the magnitude on both sides. Apply the mod of both sides. So our aim is this 2 by mod of W need to be maximum. Need to be maximum. This number need to be maximum only. You need to identify this number need to be maximum. Okay, this number need to be maximum. Clear? Up to now clear? Done. So here, what is the outputs of y? We have only two outputs. One is if the y equals to 1, if y equals to positive 1, it represented the WT of x plus b greater than equals to 1. So it's negative 1, WT of x plus b less than equals to 1. These are the two conditions only we have. These are two conditions only we have. And this is the two conditions we have. Clear? Done. Okay. So the main aim is we need to maximum this, right? 2 divided by mod of W. We need to maximum this. Also, we can also write in the another form. Maximum value of 2 divided by mod of W is also represented by minimum value of mod of W divided by 2. It is also represented like this. So here we are simply reversing the 2 on mod W. Simply we are reversing the 2 on mod W. Both are equal. Both are equal. So here, if in case we draw a marginal lines, in case this is the data points, we also know this is the data points, right? So this is a hyperplane. This is a marginal line, right? This is a marginal line. if you draw the marginal line like this, if any point lies between the marginal line and the hyperplane, that is known as a error. Is known as a error. We need to calculate the error points also. That is known as a error. So we need to calculate the error points also. So minimum of mod of W divided by 2 plus Ci summation of I equals to 1 to n eta. This is the meaning of eta. Okay, it is used to summarize the distance between the error points and actual points. It is used to summarize the differences between the error points, like a wrong points, If you apply this function, you can also calculate the errors. You can apply this formula for calculating the error points also. Clear? Okay, done. So in data we have non-linear and linear. Right now we are working for the linear. If in case if you find any non-linear data, at the time we need to use SVM kernel. SVM kernel represented for the non-linear data. So if non-linear means, for example, this is my data. Okay, the data is presented like this. The data is presented like this. So this is not in a linear format. Further, this SVM kernel it is converted into 3D. It will convert it into 3D. Okay, this is a non-linear data, right? This is a non-linear data. 2 points is a non-linear. It will convert it into 3D, like this is a non-linear data. So we have two data points, one is circles and one is intus. It will convert like a 3D. It will convert it like a 3D by using kernel. Okay, it will convert it like a 3D to view the non-linear data. That's our thing about the SVM, support vector mission. In support vector mission, we have marginal lines, hyperparameter. Hyperparameter is y equals to mx plus c. Marginal line equals to y equals to stability x1 plus b. One is minus negative format, another one is positive format. We need to identify the things. This is the theoretical information about SVM. Clear? This is a theoretical implementation about SVM. So let me show you the practical implementation of SVM also. You can clearly understand. So SVM is a support vector mission, which is a type of supervised machine learning algorithm to solve the both classification and regression. So here the implementation simply using import numpy as np, import pandas as pd. So whatever the things required, you can import. So data equals to read underscore CSV mobile price classification dot CSV. This is a CSV file. So the shape of file is 2000 rows and 21 columns, and this is the top head, and same like that it is the bottom tile. And if you want to find the data dot is and dot sum, there is no null values present in the data. So description is used, like describe is used to the statistical analysis of the numerical columns. Pandas lo velda, feature engineering velna, feature scaling velna, ఏం చేసాం null values remove చేసాం కదా, అవి చేయమని చెప్తాయి. Okay. Clear? Okay. Same data.info. If you want to provide any information, like whatever the things, what are the columns present in the data. So x-axis and y-axis data has been splitted. So the minimum point will be data is divided. So here minimum and maximum values is divided the data, and SQL model selection train test. I created train test. This is the module. From sklearn.svm import support vector classifier. SVC means classifier. SVR means regressor. Support vector regressor, support vector classifier. SVM equals to, here random state equals to 1. SVM dot fit x prime and y prime. assumed accuracy of the score, and this is the test accuracy. If you apply for the test and try, the accuracy is like this. Clear? This is a simple implementation. There is no need to worry about the implementation. Just we are writing 4 to 5 lines of code. Yes, we are writing 4 to 5 lines of code. Then this is the implementation of SVM. SVM. Harita, done?
Okay.
So this is all about the machine learning concepts. Recently we discussed about the linear regression, logistic regression, decision tree, random forest, XGBoost, XGBoost, nav-based, KNN, K-means cluster, hierarchy cluster, and DB scan cluster. Finally, we are also discuss about super vector vision, support vector vision. So these are the 12 algorithms which are present in a machine learning. So if you know all about this, you can easily pass the interviews. Will help to clear the interviews. No? So that's it from my side of machine learning. I already discussed about the feature engineering, feature scaling also. So apply for the data cleaning, that feature engine and feature scaling. That's complete about the machine learning. So next we are going to move towards the advanced level. That is the deep learning. Around it will take 4 to 5 days. We will discuss about what is deep learning, how exactly deep learning, what is the execution function, what is the optimizers, and what exactly the algorithm works, like ANN, RNN, CNN. These are the things in class, like around Monday. Monday we will discuss about the things. Okay. So that's it, guys. That's it from my side. So I hope you need to do the practice on this. If you done the practice only, you can understand it. Please go through the each and every algorithm and watch the videos once again. I hope you are already see the videos through YouTube and also driving, both the things I am providing. So try to watch the videos and try to update yourself. Try to implement any number of projects. So you need to submit me 24 projects. 12 to 24. The number is the name is like 24 is a fancy name, but you need to work on that. That's the main problem. Simple man. If you do the work, definitely you will get the experience. So